And we wanted to give you an up-close look at a nuclear reactor. It's a research reactor at Purdue University in Indiana. The school invites students from other universities to visit, do experiments, and learn about radiation. Mike Tobin live in West Lafayette to tell us more. Mike?
And John, I've been getting a crash course in nuclear science, and let me show you. This is the business end of a nuclear reactor. This is the fuel cell. These flat parts are the claddings or fuel elements. I can show you one by itself. Now, I can handle this because this is just a prop. If it was active, it would be filled with uranium. Now, I can show you some of the active fuel cells inside the reactor itself. They're deep underneath 13 feet of water. Now, the water serves several purposes. One, it does absorb some of the radiation. In a nuclear plant, the water boils, and that creates steam, turning the turbine, creating the electricity. The water also cools down and controls the reaction. Now, the one thing that is keeping this from reacting right now is you can look down to those fuel cells or the fuel elements underwater there are these big tubes going into the top of them. These are filled with an element called boron. When you talk about what's going on down in Japan, you hear about them dumping, in addition to water on top of the big meltdown there, they're dumping boric acid. The boron, what it does is acts like a sponge, if you will, for the radiation, for the neutrons that are coming off, and absorbs all of those radiations. Also, absent of the water, if I grab one of these props again, with these claddings, what happens is it's kind of like a teapot that you leave on the stove for too long and boil off all of the water. This thing itself, of course, in the form of a tube or a rod inside of a real power plant, starts to melt down. And what you end up with is this big molten pile of uncontrolled nuclear substance. It doesn't bore its way down to the center of the earth like it does in so many of the science fiction novels, but it's very, very hot for a period of time, and it continues to give off radiation. So they can't just go in and remove this stuff because it's too hot and it's too radioactive. John?
Mike Tobin, interesting stuff there from Purdue University in Indiana.